Good evening, Standoff. And our next speaker is going to talk about a very interesting topic about PowerShell obfuscation. Xavier Mertens.
Thank you for the nice introduction in Russian that I don't understand at all. So I don't know what you said, but yeah, I'm sure it was a nice introduction. My talk, as you can see on the screen, the title is "Let's Dive into PowerShell Obfuscation." I will try to explain you during 45, 50 minutes. I will try to stick to the schedule. Because I hope that there will be some questions. So I will try to have 10 minutes of Q&A after the presentation. So the idea of my talk is just to give you some interesting ideas, how you can found and understand better obfuscation into PowerShell scripts. But first, a quick introduction about myself. Yeah, I would like also to thank the organizers of this conference for inviting me. It's really an honor for me. It's the first time that I am attending a security conference in Russia, even if it's virtual due to this very nice situation that you are facing for a few months now. A few words about myself. My name is Xavier Mertens. I'm a French-speaking guy, and I'm based in Belgium. During my day job, I'm a freelance security consultant. So basically, I have my own company, and I'm offering my services to customers. What kind of service? Basically, I'm a blue team guy instead of red team. So I prefer to defend and attack. I really like to track the bad guys and to try to block them and to protect my customers. Besides this, and it's also the topic of this presentation, I'm a Science Internet Storm Center handler for a few years now. I hope that a lot of you know the Internet Storm Center. I'm also a 4.610 instructor at Science, which is the malware analysis and reverse engineering training, a very interesting one because I like malware, I like bad code, and I like diving into bad code. I'm also a blogger and the co-organizer of the BruCon Security Conference, which is organized once a year in Belgium. And besides this, a lot of other small projects. I'm really a busy guy. The idea behind this talk, I had the idea because for my research at the Internet Storm Center, if you follow my diaries, I try to hunt for bad code. I try to hunt interesting piece of malicious code to dissect them, investigate them, and try to share the knowledge, what I learn about them through the community. And that's really my idea. Sometimes, but most of the time, it's really fascinating how attackers can be imaginative when they have to obfuscate the code. So basically, when you have a malware developer writing a new piece of malware, then the idea is to obfuscate as much as possible the code to make our life, security analysis, malware hunters, and so on, to make the whole life more difficult. And it's really crazy how those people can have new ideas and can implement new ways to obfuscate the script. I really like this. So that's basically the idea of my talk. Of course, to be able to find a lot of techniques, a lot of obfuscation techniques, you have to find fresh meat. We need fresh meat. As a malware analyst, as a hunter, you need to find or everyday new pieces of malware. And this slide represents a quick overview of my my setup. So what I'm using to collect as much as possible malware samples. From the left to the right, so if we start on the left of the slide, you see that I have a lot of mail traps. So what is a mail traps? I have a bunch of domain names, very old ones. I also try to register some domain names which look like very interesting, very suspicious. And basically, I'm collecting all the mail sent to these domains. And the mail, when it's received, I just extract using a bunch of Python script. I extract a lot of IOCs, IP addresses, URLs. I also extract, of course, the attachments. And all of this is automatically sent to another tool, which is called FAME, which is some kind of a triage tool to pre-process all the samples and automatically do a basic analysis. So it's fully automated. And one sample is extracted from a mail, it is submitted, and automatically I execute a lot of commands against this malware to try to automatically see if it's interesting or not. One of these tools, for example, is to submit the sample to a CAPE instance, which is a sandbox system. So I do an analysis. So I execute in the sandbox the malware, and I try to extract more information about it, how it behaves, other interesting IOCs. Of course, I can also do some manual finding because I'm browsing a lot. And when I found interesting stuff at a customer or just we receive also at the Internet Storm Center, we get from some samples from our readers. I can also feed manually my FEM instance. And everything is then sent as tickets into a DIve instance to manage some kind of incidents. And on the right side of the slides, I have all the feeds feeding my DIve instance. I'm hunting a lot on various total using Rara rules. We receive also other reports from Internet Storm Center readers or data from customers that, of course, are anonymized. So that's basically a very quick overview of my setup, which allows me to collect a lot of interesting samples. Now, if we have a look at the obfuscation, first, when we deal with the malware, we deal with the pyramid of pain. This pyramid of pain can be designed and can be represented on almost every process. And for malware analysis, this is the typical pyramid of pain. It means that starting from the bottom to the top, you have the different type of analysis that you can do against a sample. And starting from the bottom, it's quite easy. And more you grow, more you go on the top of the pyramid, more it's difficult. So you start with automated analysis. So basically you just submit the sample into a sandbox, could be a CAPE, could be a system in the cloud, could be a commercial product, whatever, but you just submit the sample and you get automatically a nice report. Nothing special, nothing fancy, it works. Then the next step will be, the next level will be to try to do some static properties analysis. You don't execute the malware, but you analyze the file and you try to extract information from the file. Not dangerous because you don't execute the file, you just extract strings, IP addresses, import table, DLLs, and so on and so on. The next step is to do the interactive analysis. Then we go one step further because by doing interactive analysis, it means that then we will execute the sample. So it's much more difficult and much more dangerous because if we make a mistake, for example, if we analyze the malware in the debugger, but we don't control properly the malware or we don't put breakpoints at the right time, we can probably infect the system. And finally, the state of the art, if I can say, the top of the pyramid is the manual reversing, because there we will have to really do the reverse engineering part, which is fun, and we have to understand everything from A to Z. That's also the big difference from the bottom to the top. Starting with automated analysis, you can have a good overview about the malware behavior, but probably you will miss some points. If you do the manual reversing, you will understand everything from A to Z. Why? Because in automated analysis, if you have a condition, if the malware found this, it will do this, otherwise it will do something else. But probably you will never perform all the action because you don't know what are the different conditions. By doing manual reversing, then you have a complete overview and you can really understand all the conditions and all the different behavior that the malware can have. But what's the impact of obfuscation against this pyramid? This obfuscation has a lot of impact. Basically, that's why the obfuscation is important for the attacker, for the malware analysis. So the question is why they obfuscate? Simply because they impact the way we work. For example, if you do static properties analysis, you try to extract strings. If you obfuscate the strings in the malware or in the PowerShell code, you will not find any interesting strings out of the box. It's the same with interactive analysis. It means that you have to read the code and to put interesting breakpoints in your debugger. If you don't understand where are the interesting instructions, you don't know where to put the breakpoint, So you will not be able to perform a good interactive analysis. And of course, manual reversing, you have to understand the code. So you have to deobfuscate everything from time to time manually, from time to time by writing a small script. So it will basically make your life more difficult. Except the automated analysis, the obfuscation has no impact at all because we just have a sandbox executing the code, and the code being obfuscated or not will result in the same behavior. Once again, why attackers they obfuscate? Basically, they make the analyst life harder. The human eye can be confused very quickly. Just by reading the code, the human eye is able to spot from time to time interesting strings or interesting blocks of code, interesting functions. By obfuscating, you make the human blind because it just look like a big mess, a big set of characters. You will not be able to extract immediately. The eye cannot focus on interesting stuff. From an automated point of view, the goal is also to defeat all the IDS rules, Yara rules, because today, most of the content that you download from the internet is processed by different security control, different tools. That's what I do, basically. I just did show my environment a few minutes ago. If I'm also using Yara rules, so if the code is obfuscated, Yara rules will not work because in Yara rule, you expect specific piece of characters, specific suite of bytes and so on. And if you change them, it will not work. So the detection ratio will be null. And finally, by obfuscating the code, it means that for every sample that you have, you will just generate a new hash. So if you base your search on hashes, it will be less relevant because if you found on an infected workstation, you found a script which is obfuscated. If you try to search this hash on several workstations on your network, probably the malware will be different because it's really common to have a unique sample sent to multiple victims. So you will not find a hash on other computers, but they will be infected by the same malware. That's why obfuscation is so important for the attackers. Enough for introduction. Now let's dive into really the topic of today, the obfuscation techniques. So the rest of the presentation will be just samples, just slides with different techniques that I met while hunting, and I spend my time to deobfuscate, and yeah, which looks like quite interesting. The first one is very simple. We can't really speak about a very deep, a very complex obfuscation. I call this GITC, or garbage in the code. Basically, remember what I said, the human eye is bad at recognizing obfuscated code. So if you have a PowerShell script and you have a look at this, you load it into your editor and you try to understand this, from the beginning, you will not find interesting stuff because my eye just see a lot of garbage. But if you have a look more carefully, you see that some strings are starting with a hash sign. A hash in PowerShell is just a comment. So it means that this type of obfuscation is very simple because the attacker, it just put between lines of code, it just put comments based on garbage characters, based on random words, and you see that indeed you have a lot of characters. You have every line, you have one line of code, one comment, one line of code, one comment, and so on and so on and so on. Once you spend a few minutes or a few seconds to detect this, it's very easy to get rid of everything through PowerShell, of course, and you will find your code, your real code. You will remove all the characters, all the comments. How to do this? Just by using the command that you see on the first line, you will just remove all the lines and you will output all the lines which does not start with a hash character. And what you will find really the code used by the PowerShell script. Of course, This example, the code is heavily obfuscated, so you are not able yet to see end-to-end and everything, but now you get rid of all the commands, all the garbage, and you can dive in the easiest way into the code and try to understand what's the magic behind the script. So this is a very common technique, and usually it's mixed with others because this one is very easy to defeat, garbage in the code. Another one, let's go back to the roots. PowerShell is a very, very, very nice language because you can concatenate and you can represent the string in many ways. For example, you can split a string and you can concatenate strings together to make a new one. So have a look at the first example. You have $URL equals h plus TTP and so on plus blah, blah, blah. Basically, the content of URL is a malicious URL. Another technique is, for example, to use backticks. Backticks are just ignore by PowerShell. So you can do the same, you can do $URL equal, you can define it in another way, and you can put random backticks in the string, but from a PowerShell point of view, the string will be the same. Another one, you see the difference on the third example that the variable names are case insensitive. Have a look at the first one. You have URL with a uppercase U and uppercase L. But when I display the URL with only a uppercase R and lowercase u and L, you have again the same string. Also, very simple, as I said, back to the roots, but it can easily defeat a Yara hole. If you found in the first investigation, you found that the domain pound.be is a malicious one, you write a Yara hole to try to find and to spot this malicious domain, you see that easily you can defeat your Yara hole because the strings will be split in multiple parts. Very, very, very simple. It's part of the PowerShell language. Another technique also coming in PowerShell is what I call, again, shrink all the things. What does it mean? You can abbreviate a lot of stuff in PowerShell. Have a look at the first command. So you see in orange, I just do a get command echo. It's just simple. Don't spend your time to basically, that's the get command. It's just a PowerShell command to learn more about the command. So it means that you can see if you have some aliases and what's the purpose of a command. The original name is get-command, but you can shrink this and you can use command. If you use command echo, you get exactly the same result. Even more, you can abbreviate and use GCM echo. And if you do a GCM echo, you can once again execute the same command and get the same output. So think again about this from an attacker's, from a defender point of view. When you need to search for an interesting API call, to search for an interesting command in PowerShell, you have to think about all the different abbreviations that could be implemented by the user. If you have to write a Yara hole to spot this one, you have to search for get command or GCM. So it makes, once again, your life more difficult. Another one, string manipulations. As I already mentioned, strings, you can manipulate strings in many ways in PowerShell. And a technique that is really common is to use split join. How does it work? Have a look at the first line. So we define a variable called URL once again, which contains a piece of code, echo, HTTP : tilde, and you see that you have a lot of tilde. So once again, instead of concatenating strings, I have one string containing, I would say, garbage characters. The idea is to split the string into an array of multiple strings and then you join the array. So you reconstruct a new string and the delimiter will be nothing. So basically what you do, you just do a search replace. You could also do a search replace. You could say, okay, search for all the tilde characters inside my string and replace them by nothing. But the split join technique is very common. So you split the string into an array and using dash join, from this array, you will concatenate all the elements into a new string, which will be separated by nothing. So you will find http://pond.be/malware.exe. Once again, the same URL, the same string. Another very common technique is to write reverse strings. You see that the technique is the same. So I define my $URL, which contain my URL, but you see that it's reversed. So we start with HTTP so you have to read the string from right to left. How to do a reverse of a string in PowerShell? Very simple. You use two share array. So what does it mean? You split the string URL into an array of characters, and then you reverse this array. And once again, when you have an array, you can use the join to reconstruct the complete string. Based on this, once again, we find the original URL, which is probably used to grab the second stage payload and so on and so on. So you see the string manipulation are very powerful, and you have plenty of techniques like this. When I said a lot of techniques, you really have a lot of techniques. If you use $URL pipe gm, you will get basically all the techniques, all the methods that you can apply on a string. So if you have a string, you see that you can have, for example, normalize, pad left, pad right, remove, replace, split, substring, to boolean, to byte, to char, get index of any, get hash code, equals, ends with, copy. You have plenty of methods that you can apply on strings in PowerShell. This is only a subset of them because my slide was too small to present all of them. Otherwise, I should write in a very, very small fonts. It will be unreadable for you. So you have plenty of string manipulations techniques. Another common one is the format operator. The format operator, think about format strings in C, C++, or in Python, for example. Format strings is a way to build dynamically a string. I will give you an example. You have a print f, and between quotes you have the username is %s. Then you pass the variable. It will replace %else with a variable. It's a format string, and you have plenty of ways to format your string. You can specify a string, a float, an integer with %s, %d, %f, and so on. PowerShell has the same feature. But instead, it uses this notation that you find on the slides. You put numbers between brackets, curves. Sorry, it's not bracket, curves, curly curves. And by specifying the -f, you will just provide all the substrings that you will replace in the original one. So to understand this, I echo the different substring 42130, and when we will execute this, PowerShell will replace 0 by LD, exclamation point. It will replace, for example, LO, 2 by LO, and so on, and so on, and so on. So by doing this, we just rebuild a new string, and the result will be hello world. This technique is really, really, really used a lot today in many malicious PowerShell scripts. Format operator. If you want more information about this, you have a full reference of all the syntax that you can have. So follow the URL on the slides. It's really powerful, not only from a developer perspective, but it's also very powerful from an attacker perspective when you need to implement obfuscation techniques. Base64, very common. So easy to use. Also, of course, if it's easy to use, it's also easy to defeat. What's nice, it's base64 is supported by default by PowerShell. So if you call the PowerShell from a command line, you call PowerShell, the PowerShell binary, and you specify -enc, and you specify a piece of base64 data, automatically PowerShell will decode it and it will execute what's in the base64 data. Easy. Of course, base64 is very easy to defeat because you can automatically revert the decode base64 chunks of data. But the good point, it's available by default, and you don't have to implement a base64 function to encode, decode by yourself and so on. Sometimes you will find it. So instead of using the standard feature of PowerShell, attackers, they will provide functions into their code, which will encode and decode base64. Also because base64 is the most known, but you also have plenty of other encoding. You have base32, for example, which is also available. But base64 is really nice and remain very common because it's so easy to implement. The next step is Invoke Expression. Invoke Expression is the gold mine. That's really the thing that you have to find when you are investigating a malicious script for the first time. What is Invoke Expression? Usually, Invoke Expression, I compare this to eval in JavaScript, or I also compare this to exec in Python. The goal of this command, it's the same in JavaScript, Python, or in PowerShell. The goal is to evaluate, so is to parse the string that you provide as an argument and to execute it. So it means that if you have invoke expression or eval in JavaScript, you can the parameter that you will pass is a string most of the time, and this string contains some piece of code, and this code will be executed. Usually, when what I like to say, for example, when I'm teaching 4.6.10 for Sans, I like to say that if you find eval, it's evil. Because it's a very convenient way for the developer to read, to extract some code from an executable, to download some code from a C2 server, to download some code from Pastebin, from another website, and to just execute it. So once you started to investigate a script, have a look at invoke expression. But remember what I said, PowerShell is able to screen all the commands and to use some kind of restricted, a smaller version of invoke expression. The most known for invoke expression is called IEX. Most of the time you will find IEX because it's just easier to write, only 3 characters, piece of cake. But of course, attackers, they also try to replace those commands by another version, another string. Because yeah, that's very nice. Like in JavaScript, in PowerShell, you can rename functions and you can have another way to present them. Have a look at the different examples that I spotted, and there are many, many, many others. You can execute code by invoking invoke expression. The second one is just IX. Have a look at the third one. You have dex.replace d by I. So if you do echo blah, 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 a very long string containing PowerShell code, pipe dex.replace d by I, what PowerShell will do, it will replace in the string dex d by I, you will have IEX. So IEX, oh, invoke expression. So it will execute the code which is passed to this function. Another example, you will use environment variables. For example, in this case, we concatenate 3 characters. We have a look at the PS home variable. We take the character, the 21, position 21, so it's the 22. Also, from PS home, the value, we take the character 35. and we concatenate all of them, guess what? In PS home, 21 is I, the letter I, the position 24, so the position, the position 34, the character 35, because we start counting at 0, is E, so we have IEX once again. Remember that we can use backticks. So IE backtick X is IX. Another one, concatenate and use ampersand, so you can rebuild a new string. I like the next one, verbal preference. It's another environment variable. We converted it into a string and we extract two characters. The first one, well, position 1 and position 3. Then we add an X, and because we had an array, we do a join and we rebuild the IEX string. So IEX is really, really the key point that you have to investigate. And you will find plenty of different techniques. I wrote a diary on the Internet Storm Center website a few weeks ago, I think. And I received a lot of comments from people who said, oh, Xavier, it was very nice, but I also spotted this technique, this technique, this technique. And so I'm still compiling all the different version of the IX string that you can find in the PowerShell malicious script. So it's really very important to spot and to have a look at Invoke Expression. Another one, is it binary or not? If you have a look at this code, when you read it like this, remember that the human eye are very bad to spot malicious code. When you read this, you can say, bah, it's just a piece of binary code. We have zeros and ones. But if you have a look carefully, you will see that in this piece of code, you have a lot of lowercase L letter. Have a look carefully at the slide, and you will see that you don't have only zeros and ones, you also have L letters. What do we do? But we will just split the string. An idea is to place in the code a lot of garbage characters. And in this case, what we do, basically, we apply the same technique. We split these very long strings containing binary characters, and we split using the delimiter L. You see that we can split, we can have different ones. We can have a T, we can have a tilde, a P, A, and so on and so on. But in this case, we have only lowercase L, because it's the one which looks like a 1, the number 1. We have, when we split this, we have an array. We convert all the elements of the array into string, because we have then binary, so we convert them into characters. And then what we do, we just concatenate everything and we recreate a new string. So basically, what you have on the top of the slides, deobfuscated, is the last line, which is new object net.webclient download file, once again, http pound.be, blah, 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 blah. So this very nice obfuscated string, basically, if you pass it to an IEX, an Invoke Expression, it will download a file from the internet, from a website, and it will write the result, the content of the content of the HTTP request into the file malware.exe. The next step probably will be to execute this file from the file system. So once again, keep this in mind. It's not always binary. Read carefully and try to find to spot very interesting stuff in the code. Another one, you see that we go deeper and deeper into the obfuscation. This one is also very nice. What do we have? We have a function G, which, not the function, sorry, the variable G, which contain a set of instructions. You see that $G, it's like a block of code. So inside G, we have a block of instruction, and you can see that all the instructions are separated by semicolon. So you have $T equals $args, semicolon. Then we have a string. We convert some stuff. You see that you have a substring. Then you have also some replays and so on. So it looks very interesting. The idea behind this is then to call this block of instruction and to pass the different parameters. That's the second line. The second line is we define a block that will be executed, $ between parentheses. We have a dot. Dot in PowerShell means that we will execute. So we will execute the block of instruction represented in $G. And this is the parameters that we pass to $G. When you execute this, what you will have this HTTPS : / and a number. For those that don't know, this is a valid IP address. You can also represent an IP address by a long integer, a long value, sorry. So if you convert these very long numbers into an IP addresses, basically you will find what you have on the bottom right of the slides, 213.252.244.193. It's a very common way to hide an IP address, to hide the URL inside your code. This one is start to be quite complex to understand. We can also go deeper. Then a guy did a very, very nice research and tried to convert characters into some very specific strings. Let's have a look at the function GetEncoded on the top of the slides. You will see that this function will just replace. It's a bunch of replay. You see, you have a $_, which is the parameter that we have to the function, and then we will replace numbers by a string. And the strings look all the same, $ between curly braces character. That's a way to encode a string. Because what do? Let's call this function node. So we call GetEncoded and we pass the string that we would like to obfuscate. For example, hello world, simple example. The age character is replaced, so the function converts the age into the ASCII value. What is the ASCII value of age? If you compare on the top of the function, it's based on the ASCII value of age is a 2 numbers value, and we will replace those numbers by the corresponding strings. So you see that it's a nice way to make your function really, really impossible to read. The result of this, hello world, will be the nice string that you see on the last line of the slide. So you convert the character into the ASCII value, and then you replace all the numbers by a string, which looks really, really weird, because don't try to read this and don't try to understand this by heart. If you do know the opposite, because of course we encoded, so we are looking for a function to decode, of course. If you do this, you define a function to revert this, basically you pass your string to the function and you find back the hello world. It will take a lot of time to explain everything and to go very deep into this technique. I did not wrote this technique. I just, a guy did a research about this, and you have the link on the bottom of the slide. So if you're interested, just have a look at this URL, and the guy explained really step by step how the obfuscation works when you need to have the function to encode and the function to decode. Sometimes we also have a lot of downloaders. So what is a downloader? In this case, the content is downloaded from a third-party website. And what we do, it's a nice way, of course, to obfuscate. It's not really an obfuscation, but the malicious code is not present in the PowerShell code itself that you are analyzing, but it will be downloaded from the internet. So by doing the command that you see on the bottom of the slides, you have the IX, you do a download string, and everything that is downloaded from pound.be/payload1.txt is some kind of a PowerShell code that will be executed, and the content of this payload is just echo hello world. This is typical for fileless activity. So we don't write malicious code on the file system. It's just downloaded and executed automatically by PowerShell. You can, of course, you can have multiple layer droppers. Here we have something which is interesting because we have a payload which is downloaded, but the payload is encoded in base64, but is also compressed. So it means that you have, before being able to call the invoke expression, you have first to decompress the data that you received, to convert it from basic to decode the base64 string, and then to decompress it. So you can mix everything. You can download something from the internet, but it will not be readable code. It will be compressed, it will be encoded, it will be XORed, it will be obfuscated more and more, and the code on live, on the fly, it will decrypt everything, decode, and execute it. Fileless malware. Another technique that I also spotted a few times is to use the PS credential technique. PowerShell has a very nice feature, PS credential, which is a set of functions to manage properly credentials. Basically, why do you need this? When you have to deal with passwords and you have to, for example, to contact a URL or to contact a FTP server, to contact a SMB share, I don't know, to connect on a resource using credentials, from a developer perspective, it's not the best practice to have credentials stored, hard-coded in the code. By using PS credential, you have a lot of techniques that are used to manage those credentials. Of course, you store data, so the data that you can store in PS credential can also be malicious. That's what I found here. So basically, what you do, you create a new PS credential, so a new management automation PS credential. You have a lot of code inside it, and by using the get network credential.password, you will extract, you will convert the data, the password, basically, in the PS credential object. The password contains malicious code that you will execute. It's a very, very nice way to distribute malicious code using this technique, because you will not see it by default, and it's quite difficult to read it or to extract it and to find it using error roles and so on. PS credential is very common. You can also have DLL injection, of course. PowerShell has a very, very deep relation with the operating system. So all the API calls present in Windows, you can call them from a PowerShell script. So you can load a DLL into PowerShell, so you can add new features to your PowerShell script. Have a look at this example. What we have a specific object which is base64 encoded and also gzipped, compressed. What we do, we just decode it, decompress it. So we have a binary object which basically it's our DLL. What we do, we load the DLL into the process, the PowerShell process, and all the functions provided by the DLL are now available in PowerShell itself. So have a look at the three last lines. You have lu1, ghpi, dot, blah, 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 and so on. Basically, those functions are provided by the DLL. So it's a nice way to add malicious code into a PowerShell, which looks by default not malicious at all. Well, not malicious. If you see that a PowerShell script does try to load a DLL decoded from a base64 string and so on, yeah, it looks malicious, but it's a nice way to obfuscate it more code. That was a quick introduction to obfuscation. Now, of course, the question, because I would like to give you some ideas how to deobfuscate, because if you are working in a team of incident handlers, if you are doing some malware analysis, it could be interesting to know some techniques to deobfuscate the code. Of course, the first one is to do an automatic analysis, because once again, remember my pyramid of pain, malware analysis, automatic analysis, sorry, the obfuscation has no impact on the sandbox because the sandbox just read the code, execute it, so it will automatically deobfuscate it. So it's the first step. Sometimes it will work, sometimes it won't work. It depends. But it's always nice to have a look at a sandbox. We also have some frameworks. For example, Powerdrive is a project that implements a lot of techniques, a lot of functions to try to deobfuscate automatically a PowerShell script. Have a look at it. It may work sometimes, once again, sometimes it works, sometimes it does not work because the obfuscation technique could have been implemented by the developer in a very easy way. But sometimes the malware developer, it will write its own obfuscation technique. So in this case, Powerdrive will be useless, but it's also a good idea to pass your script to Powerdrive. A very nice tool is, of course, it's my favorite one, is to use Powershell IC. PowerShell is installed by default on every modern Windows computer. But instead of, in parallel to the interpreter, you also have PowerShell IC, which is the complete environment to develop PowerShell code, like with a GUI, a nice GUI and so on. And guess what? This PowerShell IC has a wonderful debugger with all the features from a debugger. So it means that you can put breakpoints, you can investigate functions, you can interact in live with your PowerShell script. But be careful, because if you do this, you do, remember the pyramid of pain, you do the interactive analysis. So it means that you interact with the shellcode. So you run the shellcode basically. So if you forgot to put a breakpoint, or if you put your breakpoint on the bad line, guess what? The PowerShell will execute and you will probably infect your computer. So it's always a good idea to do this in a sandbox, in a VM, and of course, not on your corporate laptop, of course. But you see on the screenshot that you can define a breakpoint. And once the breakpoint has been reached, you can interact with on the console and you can display the content on some variable. So you see that I did a zoom. So I define a breakpoint on IEX. So just before executing the IEX, I put my breakpoint because I was interested in the variable $OHTMT and so on and so on and so on. So when you do this, you reach the breakpoint and you can automatically display, you can execute other PowerShell commands. And if you try to display the content of this OHTMT variable, which is basically, an array, you will find a dictionary, sorry, you will find a lot of interesting stuff. You will find URLs, you will find a user agent, you will find some domain names, and so on and so on. So debugging with PowerShell is really, really convenient. The biggest issue, of course, is that you need to know where you put your breakpoint. That's why you need to do some pre-analysis and to try to learn a little bit about the script, because if you spotted IX, usually that's the right position where to put the breakpoint, just before the IX, because it means that the PowerShell will do the job. It will try to download the code, it will deobfuscate it, it will decompress it and so on, and then it will pass it to IX. If you stop just before, you can display the content of the value and you can see what the malicious code will do. So PowerShell IC is very nice. How can we detect all this PowerShell activity and so on? So first I will speak about the blue team side. How can we detect this? Of course, you have to log everything. It's just one slide, but I think it's very important. PowerShell has 3 logging modes available. You have module logging. It records the pipeline execution. The event ID, which is very important to have a look at, is 4103. You can also have script block logging. It will record the block of code when they are executed, but like as they are executed, so you will see really the code that is executed. Transcription, it records the PowerShell session also with inputs and output exactly like if you were in a session and you have this stored in text file. My recommendation, if you would like to detect suspicious PowerShell activities, have a look at Sysmon, of course. Sysmon remains your best friend to spot malicious PowerShell activity. If you are interested into PowerShell logging, my recommendation is to have a look at this cheat sheet. It contains a lot of useful information to implement into your SIEM, your log management solution, and so on to detect malicious PowerShell activity. Of course, I had to present something because if we speak about blue team, how to obfuscate, sometimes it could be interesting for red team people who are doing pen testing, people doing red team activities. You can also, from time to time, have some requirements to obfuscate because you will write your own PowerShell code. How to do this? Just some frameworks, just for your information. There are frameworks available. Keep in mind that most of the time, the obfuscation that is implemented, that is added to a script, the developer, they don't lose their time to write their own obfuscation technique. They have scripts to automate this. So if malicious people, if bad guys, they have this, of course, good guy can also use this for red team exercises. This is a small list of interesting projects that you can use to obfuscate your PowerShell script. So if you would like to play on the other side, on the dark side, have a look at them. That was my last slide. So I'm happy because I finished in 51 minutes. So we have a few minutes for questions, if you have some. If you would like, if you don't have time to write your questions, if you would like to contact me because you have an idea, you would like more information about specific technique, this is how you can contact me through my Internet Storm Center address at Sans, my private address. I'm also quite active on Twitter and my LinkedIn profile. So I hope that you enjoyed the presentation. It was just a small presentation, a small subset of all the techniques that you can find. But yeah, I hope it was interesting for you, and I'm open to all questions. Thank you very much.